Hi, my name is Alex Vojka and I'm a technology PR specialist for Imagination.
So here's a whole bunch of imagination-powered devices, right?
Yeah, so what we have here is a range of Android and iOS mobile devices with PowerVR GPUs. What we're showing here is some OpenGLES 3.0 demos that we have, highlighting the latest features of our GPUs. So for example, in this demo we have high-end features such as 4K textures, HDR rendering.
Which is this tablet?
This is the latest iPad.
With the A8X?
Yes.
So this is the most powerful imagination GPU ever,
Yes.
right? What on the market? What is that?
So we have a range of families that cover the high-end scale all the way to the low-end. So we have PowerVR Series 6 and PowerVR Series 6 XT and 7 XT at the high end, and then we have PowerVR Series 6 XE and PowerVR Series 7 XE at the low end. So this enables us to target a wide range of markets and a wide range of devices, like I said, from the affordable category that's shipping right now in high volume all the way up to premium devices like some of the devices that we have here.
So this is the high-end
Yes,
GPU.
this is one example of a high-end premium device, and there are others as well that ship with PowerVR. So we have others here running Android. This is, for example, the latest phone from LG, the LG G3 screen. So this uses the LG's in-house chip called the LG Nucleum, using Big Little CPU and
Is that an octa-core?
Yeah, it's an octa-core with a 4-cluster PowerVR Series 6 GPU.
Is it the Cortex A15A7?
Yes.
And that's a powerful GPU.
Yes, and a very powerful GPU. Like I said, a 4-cluster Series 6 GPU. Another example of a tablet that we have here running Android is the Amazon Kindle Fire. So this is running the MediaTek chipset with a 2-cluster PowerVR Series 6 GPU.
All right. So Amazon,
Yes,
Apple, LG, those are all big customers.
Yes, Dell as well. This is another tablet running Android. So this uses the Intel Atom SoC with, again, a 4-cluster Series 6 GPU. So yeah, we can show here a range of devices.
So how do you work to integrate with the ARM?
Yeah, so our architecture, our PowerVR GPU architecture also works with the 3 CPU architectures that are currently supported by Android. So you can see here examples of ARM CPUs, Intel CPUs, obviously MIPS as well. So we are, as far as PowerVR GPUs goes, we are architecture independent. We work with and welcome any architecture, any CPU architecture out there.
But you do a pretty high integration of performance to power.
Yes,
but integration with what happens on the ARM side too, right?
Yeah, so we work closely with all of our customers to make sure that they get the performance they want within the power budget that's characteristic of mobile devices. Also ensuring that they get the smallest area because that influences the cost of devices. So it's a cooperation between us and the silicon vendors. So customers like Allwinner and Rockchip and Intel and MediaTek. All these customers are customers that we work very closely with to make sure that PowerVR works very well with the platforms that they have.
You have hardcore engineers optimizing and optimizing and optimizing.
Exactly. Yes. So we
power
have,
to performance.
Yes, we have a very big. We have the world's largest team dedicated to graphics development, both hardware and software. And we are showing here, the demos that we've worked on.
Where are your teams based?
So we have teams based around the world essentially. We have teams based in the UK, we have teams based in the US, we have teams based in Australia, New Zealand, we have support teams in Japan, China, South Korea, China, all the places where our customers have offices.
And you do a GPU compute, which is all these heterogeneous multi-processing systems and GPU compute is a big deal for the future, no?
Yeah, so we are a member of the Kronos group that designs and maintains OpenGLES and OpenCL, which are two standards used for graphics and compute. We also are a member of the HSA Foundation, which is working together to bring heterogeneous compute to mobile devices. So all these things...
This is a big project.
Yes, yes.
It's an important, big future project.
Yes, and we are working on MIPS and PowerVR to make sure that they are HSA compatible.
And you provide the best GPU for Intel to use on their tablets?
Yes.
Because they also have their own, but I guess you better, right?
Yeah, so they have a dual sourcing strategy where they use their own Intel HD graphics for certain devices, and they use PowerVR for smartphones. You've seen the Asus Zenfone 2 being announced, and other smartphones using Intel chips with PowerVR. Also, some of the Dell tablets and some of the Asus tablets as well using Intel Atom with PowerVR inside.
So what are we looking at here?
So this is an example of GPU compute moving away from just being a scientific application and being deployed in actual devices. So what we have up there is a smart camera that's monitoring and analyzing our movement. This is a company called Vidaro. So they are using an OMAP, a Texas Instruments OMAP chip, and using our PowerVR GPU inside that chip to do GPU compute. And what they're doing here is they're looking at the video stream, analyzing how tall we are, where we're looking at, if we're moving in and out of a queue. This is for an application that's relevant for retailers, so they can know, what consumers are doing in their stores, if they're getting in line, if they're leaving the line, they can open up a new cash register. So this is just for them to make their products and their store more efficient.
Which TI is that?
It's an OMAP processor.
So it's maybe the OMAP 5.
Yeah.
And then it has powered GPU compute. You have since which generation?
So we've been supporting PowerVR. We're supporting GPU compute on PowerVR since Series 5. So Series 5.
530, 540 already?
540, yes. We had some demos, some OpenCL demos running on 540, exactly on the Texas Instruments.
That's been a while, 540, right?
Yeah.
2-3 years?
Yeah. We were actually the first mobile GPU vendor to be certified with OpenCL. Yes.
All right. And what are we looking at here?
So what we have here is we have now expanded into new territories. So we're doing things like image processing and image processors. So what you're looking at here is an FPGA demo of our ISP architecture called PowerVR Raptor. And this is a architecture that can be used for imaging inside wearables, mobile devices, and automotive. It can scale very well in terms of performance. It can handle things like 16-bit color depth. It can handle things like 4K resolutions. And this is obviously very important for automotive applications or for mobile applications, being able to capture high-quality videos and high-quality pictures. And this is something that a lot of silicon vendors are interested in. So building better mobile cameras for mobile devices. It's
really important to now. Some of them are doing 4K.
Yes.
4K
capture.
4K 30, H.265 encoding.
Yes. So this is perfect for those applications.
But you do the kind of ISP stuff that encodes video?
Yes. And we have an example here of how people can use encoding in a smarter way. So what we have here is an algorithm we call region of interest encoding. And you can see here to the right how we are doing GPU compute to detect the face, and within a limited bandwidth scenario we allocate quality where it's needed around the person's face, whereas the elements in the background can be blurred out. And this is a useful application for things like video conferencing, where obviously you want to focus on the person and less on the things that are happening in the background.
So what does it mean, PowerVR video?
Yes,
it's
video encoding and decoding. Yes.
Encoding and decoding. When these kind of devices have PowerVR, you do that. You take care of that.
Yes,
or do they also do it separately sometimes?
So we provide both the PowerVR graphics, PowerVR imaging, and PowerVR video IP, so the companies can build complete solutions from camera all the way to display. And this is an example of a smartphone using PowerVR video encode and decode. This is the Huawei Honor 6 smartphone.
So they use PowerVR and with the high silicon
Yes, chip. So it's a high silicon chip using a PowerVR video encode and decode. It uses a competing GPU. Yes, yes.
All right.
And then over here we have a few of our MIPS demos. So what we're looking at here is a development platform with the latest MIPS Warrior CPU. What we have here are two operating systems running simultaneously, side by side. So we have a real-time operating system and Linux running on the MIPS microcontroller. So we've put full hardware virtualization inside the MIPS microcontroller, which enables you to do things like more secure devices. So imagine your wearable device, monitoring your health, handling your mobile payments, but also doing things like running the Android Wear OS, so getting notifications and all sorts of things like that.
So in 2014 you bought MIPS?
Yeah, we acquired MIPS in 2012, yes.
2012?
Yes.
Oh, that's already a while ago.
Yes, yes.
And
yes.
What's the idea there?
So the idea was to provide an alternative for the CPU IP business, so that silicon vendors have a choice between ARM and MIPS, which leads to obviously more innovation. But also, this is another example of how, like I said, as I was saying, we can build more secure devices. So, like as I said, you had a wearable running on MIPS, and you'll see that in a moment. And if you have mobile payments and health data and all this information that's personal to you, you want it to be kept separate from the Android operating system. In case something happens to Android, you don't want somebody to hack into your personal data. So this is a proof of concept of whatever I do under Linux will not affect what's happening with everything else.
All right. So how much of MIPS microcontrollers are there out there?
MIPS has shipped in, just last year, has shipped in over 800 million devices. A lot of those are microcontrollers, but also things that we like this, which is high-end networking equipment. So 64-bit MIPS CPUs shipping in devices from Cavium and Broadcom. So really high-end, many-core processors for the enterprise space.
So it says Engenic.
Well, these are the
tablets.
The tablets, but the chip here is a Cavium.
So who's making MIPS tablets? Engenic?
Engenic is making MIPS-based processors for mobile and for wearable. You can see here these tablets running Android and running Firefox OS.
Are there some other makers making MIPS?
Yeah, we can see that in a moment. We have a company from Shanghai called Geek. So they've built a smartwatch running Android using Engenic silicon. The really cool thing about this device is it has a dual-core MIPS processor that defines power islands. So when the device is on, it will use the GPU, the CPU, the video, and so on. When the device is in standby, it will use a LCD
transflective kind of thing.
Yeah, it powers off processors in the chip, so you only have the CPU active just for doing sensor monitoring. Another cool thing about this wearable is it has a dual screen technology, so when the device is in standby, it uses an e-ink display, and when the device is switched on, it uses an LCD display.
But it's not e-ink, no?
It is e-ink. It is a combination of e-ink and LCD. That's why it's dual screen technology.
Real e-ink is there?
Yeah. So transparent e-ink when the device is in standby, and then when you switch it on, it's an LCD display.
Transparent e-ink?
Yeah, it's a new technology that the company called Geek has developed. Yes.
All right. It's got to be some kind of transflective LCD, no?
Yes. And also what they're doing is, because they have a combination of a power-efficient MIPS processor and this dual-screen technology, they are achieving 3 to 5 days of normal use and about 15 days of...
Did they have a booth here?
Standby. No, but there will be at MWC.
All right. What is this one?
This is another wearable. It's a more affordable wearable from IP, and again using Engenic silicon for a smartwatch.
So they're both Engenic?
Yes.
All right. And here we're looking at Engenic also?
Yes, so this is a development board that we've recently announced, running both Linux and Android. What we have here is Linux. We're playing Quake 3 under Linux.
So you can hold it up right here. This is
That's the Creator CI20.
CI20.
Yes, yes. And what's really remarkable about this development board is the fact that it has very low power consumption. So we can see the power measurement here. We're getting about, we're playing Quake 3 at full HD resolution, and we're drawing about 2.7, 2.6 watts maximum. And this is truly remarkable because this is total board power.
All right. So you are showing a whole bunch of more things around here at the booth?
Yes, let's move on over there, and I can show you a few other demos. So what we have here is a range of speakers using our Ensigma and MIPS processors. These are Wi-Fi speakers. You can connect them over your existing Wi-Fi network. You can add as many as you wish, and then there's an app called Pure Connect, which enables you to, available for iOS and Android, which enables you to turn them on and off, stereo pair them together so you can build multi-room audio solutions.
Is it kind of like DLNA?
It's not DLNA. It's actually based on Wi-Fi. So it uses a technology we call Cascade, which enables you to do this tight synchronization between connected speakers.
All right, so this is the speaker area.
Yes, and we also have another demo that I can show you. This is a company called Securify, and they've built this MIPS-based router that has Zigbee functionality, which means that it works as a traditional Wi-Fi router. So it has a touch friendly user interface. You can do things like configure it and change the settings, but it also has Zigbee, which enables you to connect multiple sensors to it. So we have here a few sensors. We have a motion sensor up here, and we have a light sensor here connected over Zigbee. So what we can do is we can control them remotely, either from the main screen, so we just switch the light off, or they have an iOS and an Android app, so you can do that over with your tablet or smartphone as well.
So it's a hub router.
Yes, exactly. A combination of a home automation hub and a traditional Wi-Fi BGN AC.
I filmed them, I think, last year, so it's been out for a little bit.
Yeah, this is the second generation. So the first generation was only Wi-Fi router, and this is Wi-Fi plus Zigbee.
Zigbee stuff. So now it's a more smart home. Before it was just a router. That's it.
Yes. And this is now running on
It's some kind of Linux.
Yes, and it's now running on MIPS CPU. Yeah.
Cool. What are you talking about? The IoT? You're going to be part of that?
We also are very heavily invested in IoT development. So what we have here is a platform we call FlowCloud, which is a IoT platform for software development. So what we have here is we use we showcase some of our partners using FlowCloud for things like temperature and monitoring and humidity monitoring, and also for things like healthcare. So these patches are connected to the cloud with FlowCloud and monitoring your temperature, your heart rate, your vital signs essentially.
All right. So how big is Imagination?
So Imagination is quite a big company. We have about 1,700 employees distributed worldwide. So we've grown a lot.
So not just making GPUs?
Yes, like I was just showing you, making video, making ISPs, making CPUs. We're now getting into the maker market with a Creator CI20 board, making Ensigma for Wi-Fi and Bluetooth.
So one of the crazy things is potentially GPUs that are fast enough to be like PlayStation 3 or PlayStation even 4 quality. This is happening this year or next year?
Yes.
It's going to be crazy, right?
This is happening this year and next year as well. So what we actually have here is all the features that were previously available in consoles and the desktop space now running on a mobile device. So this mobile device is controlling this screen here. So as I was saying, HDR rendering, 4K textures, physically accurate lighting, all these effects that were previously available in console devices are now able to run on mobile. And with the future, we believe that in the future people will actually be able to run ray tracing. So we have a ray tracing demo over there showing what the future of graphics will look like. So this is a technology called hybrid rendering running on a PowerVR Wizard GPU. So you can see here the amount of effects we can show with ray tracing. You can see the reflections and the shadows. They're all perfect and look photorealistic. So I can zoom in and you can see the quality of the reflections and the shadows. So this is coming in about 2 to 3 years.
How about 4K gaming? Are we there yet?
4K gaming is coming to mobile as well. So
this year or next year?
We believe that sometime in the future. So the new Series 7 XT family is able to scale up to that level of performance.
At least 30p 4K would be pretty amazing from a phone.
Yes.
If you had some game, maybe it doesn't have to be full 4K, just more than 1080p.
Yeah. So
something like 3K or something.
Yeah. PowerVR GPUs are already used in smart TVs running at 4K resolution, but that is in the premium market. We see the 4K now moving into the more affordable market, so PowerVR will be used that.
But that's where the future of gaming is also. It's where you develop for 100 million, you develop a game. You don't want it to work only on the PlayStation.
Yes.
It needs to be on the home console, on the tablet, on the phone.
Exactly, and that's
on Android and on maybe iOS also. But
yes. And that's
the smart TVs and everything.
So if you look at the big game engines, Unity and Unreal from Epic and others as well, they're now moving to a sort of mobile-first approach where their game engine is optimized for mobile and then at the same time optimized for console and desktop. So developers can start building titles for all platforms from the start. So you have the same game running on multiple devices, on your tablet or smartphone where you're away from home, and then you get home, you can play it on your console or on your desktop PC.
So that's definitely an important thing for them in the future, to just invest once and it should work everywhere.
Exactly, yes.
And how about interoperability between the different GPUs?
Yes, and
is that possible? Does that work?
Yes, so obviously.
Or do you have to develop for PowerVR and then for Mali and then for Adreno and then for? Can you do once and for everything?
Yeah. So what usually tends to happen is Android, like as I was saying earlier, supports 3 CPU architectures: MIPS, ARM, and Intel, but also supports multiple GPU architectures: Adreno, PowerVR, Mali, Vivanti, and others, which means developers have a wide range of combinations that they need to optimize for. So Android is making, and Google is making it easier for developers to build cross-platform games by providing better tools, and we also work with the game developers so they can understand MIPS and PowerVR and optimize for them. Essentially what you can do is you can build a standard version of the game that runs well on all devices, and then you add features and you optimize and you build new features depending on what device you're running it on.
Are you open source?
So we provide a level of open source support. We have the kernel drivers are open source, and then the user space is in binary form. But we're looking at growing our investment in the open source community. We'll be making some announcements soon. So we have a few partnerships ready. So we're looking forward to see what's happening.
Because I guess some of the guys making Ubuntu stuff or Chrome OS or Chromium OS,
yeah,
and all that stuff just needs to be able to kind of like work smoothly with video acceleration, with the good GPU and everything.
Yeah, so
is that possible?
Yeah, we're working with Google, and actually we've been in touch with them about getting more and more involved with the open source community and making sure that Chrome OS and Firefox OS and the Linux-based operating systems, including Ubuntu, run well on PowerVR and on MIPS. It's a very different space than desktop because desktop is has a few established players and they've been doing this for a long time, whereas in the embedded development market, it's still coming along.
So how do you compare with Mali? Performance, everything.
Yeah. So in terms of performance, PowerVR, what we've done is we've designed a family that scales very well from low-end devices to the high end. So in terms of the high end, we offer the best performance per milliwatt, and at the low end we offer the best performance per square millimeter. So if you go on to use the popular benchmarks and GFX Bench and others, you see that PowerVR offers better performance than the competition.
And each of these different different GPUs have different ideas of how to do things.
Exactly.
And different ideas might be good, and you have a different way of doing things than the Mali and the Radeon and the other one.
So we have a unique technology called TBDR, tile-based deferred rendering. We've started out in the console space, so if people remember the Dreamcast from Sega,
that was cool.
That used a PowerVR GPU. That was one of our earliest PowerVR implementations.
Is that when you started being a company?
Yes.
Or did you exist before?
So we probably our biggest initial design win was in the console and desktop space.
So you started with Dreamcast?
Yes. In terms of the PowerVR being a brand name, it was Dreamcast.
And those games actually look, I would say somehow, they look better than the current smartphone games.
Well, it depends. I mean, if you look at casual gaming, it's still casual gaming, so it's simple.
I would even say that the Super Nintendo is better looking than Angry Birds. But I mean,
yes. It just depends what you're comparing, obviously, because you have different types of game. But yes, we started in the console space, and then we saw that mobile was picking up, and our CEO had a vision of mobile devices with touch screens and having a GPU, and we started investing in that space, and we were the first to be involved in mobile devices.
And you are a partner of ARM, no? You're also a competitor, but you work together, right?
Yes, we also work together. We work together, like I said, for the Kronos Group, for the HSA Foundation, and various other groups and foundations. Like I said, we welcome competition. We believe that it drives innovation, and we also believe that we should work together when we. And
you're friends. You're not suing each other or anything, right?
No, we're not. No.
Right. Okay.
No. We believe that technology. Having better technology is what makes a company better, not.
Actually, on MIPS you shared the patents or something, right?
So when we acquired MIPS, there was part of the patents were shared between a consortium of companies, including Imagination and ARM, and then we retained some of the original patents as well. So yes.
So cool. Looking forward to crazy more innovation in 2015.
Yes.